All right. So converting 4, 5, 6, 7, base 8, base 10. Okay. Got it. Let me see.
Yes.
Okay, fair enough. That's why we're doing this. So, um, so you guys, in Zoom, we were looking for 4,000, excuse me, 2,430. Is that correct? 23. Oh, no, I added another 7. I must have accidentally hit the button. So right above that, I got 2423. 2,423 is what we were looking for. So just to review, if we write it out in expanded form, means this. So that's our base. So this would be one's place, power 0, then 1, 2, 3. So we're going to write 4 times 8 to the third plus 5 times 8 squared. 6 times 8 to the first, and then plus 7 times 8 to the 0, which is just 7. Since 8 to the 0 is 1. Anything to 0 powers 1. Now, you could go ahead and just find this product, find that product down the line, and then add that up. And that will come out to be 2,423. Now, you don't have to write it out. Calculator shortcut, which is what I did when I, figured out what the answer would be. You can go start with the digit on the left times the base, and then hit equal every time. So 4 times 8 equal plus the next digit equal, then plus or times 8 equal, then add the next digit equal times 8, and then plus 7. Good? All right. All right, so that's going from another base to base 10. So let's do it the other way. And let's take 8,362. This is in base 10. And we're going to convert this. Oh, I don't know. Let's go base 7. So 8,362. And we're going to convert to base 7. All right. I think you might have been talking about. That's exactly what I said. Just put it that way. There you go. Same thing. Yeah, I was going in my head, so I was writing the dates down. That's the only thing I was doing, but yeah. Same math. We got it, yeah. Oh. Okay, so the process you're using is not to convert to another base. That's what we'll have to do. We'll get, perfect. Yeah. How do you do it? Okay, what you did. All right. All right, so the answer we were looking for was 33244 base 7. So 33244 33244 base 7. All right, so let's see how we get there. So what we need to do is divide. So we take whatever base we want to convert to, and which is 7 in this case, and then we divide it into the 8,362. So just take your calculator and you'll go 8,362 divided by 7, which is going to go 1,104 times. Now, we need to find the remainder of that division, because you're going to actually get 1194.571429, which is not the remainder. It's the actual fraction remainder of the divisor. So what we'll do is we'll go 1194 times 7, which gives me 8,358, which is what, 4 less than what we divided into. So we know the remainder is 4. And now we're just going to continue this process until we hit 0. So it's 7 into 1194. Which goes 170 times. And then we'll go 170 times 7, which gives me 1190, 4 less than that, so the remainder is 4. And 7 into that, 170, so 170 divided by 7. And then go 24 times, and some odd remainder, so 24 times 7. 24 times 7 is 168, which says then the remainder is 2. And you get to a point you really don't need a calculator. At least 7 goes into 24 3 times with the remainder of 3. When we get to that point where what I'm dividing by is less or greater than what I'm dividing into. So 7 goes into 3 0 times, and the remainder is 3. That digit is there. Then read this bottom up. So base 7, this would be 3 3 2 4 4 base 7. All right. That's wanted to do a quick review of converting from another base back to base 10 and going from base 10 to another base. So I'm going to go ahead and erase this. Good. Good. Checking chat. I don't see anything chatted in there. So here's the problem for today. So let's say I've got 3 4 5 6 2 put brackets around that, and I'm going to say put 7. Now, what that notation is indicating here is that this number is not base 10. It is 3 4 5 6 base 7. And this number is not base 10. It is 2 2 5 base 7. So as of right now, our only way we could actually really go about this problem is to take 3 4 5 6 base what 7 and convert it to a base 10. And then also do the same thing with what 2 2 5. So there is a way you could do the problem without me saying anything else. So let's do that real quick. So then this would be 3 times 7 plus 4 squared plus 5, 7 and plus 6 times 2. And whatever that comes out to. Then 2 2 5 will be 2 times 7 squared. 2 times 7. 0. All right. So we'll do the arithmetic and figure out the base 10 equivalents. And then double check with everybody, make sure we're all got the same answer. Okay, assuming I push buttons correctly, I'm getting 1,266. All right, got confirmation. All right, so, and then 225 base 7. So actually, this one's at 49 times 2 plus 14 plus 5, getting 117. Okay, so over here, I'm now just going to go. Those are now in base 10. We'll just now using ordinary arithmetic. What would I do? Oh, 6 plus 7, carry the 1, right? What am I carrying over? Actually, a group of 10, right? So it's 13 is one group of 10 and 3 ones in base 10. So then that would be 8, that would be 3, and that would be what? 1. Now, somewhere I need to now what? Because I want this answer in base what? 7. So now I'm taking 7 and now converting it, taking 1,383 and converting to base 7. So here we go. 1383 divided by 7. Now that would go 197 times. 197 times 7 gives me 1379. So that gives me a remainder of 4. And we'll continue on. 197 divided by 7. We'll go 28 times. 28 times 7 is 196. So that's a remainder of what? 1. And 7 goes into 28, what? 4 times on the dot, no remainder. So remainder is 0. Then 7 goes into 4 0 times remainder of what? 4. So this answer, 3456 base 7 plus 225 base 7 appears to be 4014 base 7. Probably, if I was just doing that problem myself, I could have done it a little quicker, the way we did it. But it's still kind of cumbersome. So let's see if we can find an alternative route. That is, let's do the arithmetic in base 7, not, or at least not convert each of the 2 numbers to base 10 and add them and then convert back to base 7. Let's see if there's a way we could do this and without a calculator. So, and come up with the same answer. So what I'm going to do is, I'm going to come over here and we're going to do a lot of mini conversions. That is, I'm going to take this, I'm going to add these 2 digits up like it was base 10. 6 plus 5 is what? 11. All right. Now, I want to have some room for some scratch words. So I'm going to erase this portion here. Now, this is a Cunningham term. You will not find this in a book anywhere. I'm going to put this in condensed expanded form. So you'll see what I mean in a second. Because these numbers are going to be very small. What I'm going to do is I added 6 plus 5, I got 11. I'm going to convert that 11 to base 7. But it's a small number, so it's not like I need a calculator. I don't need to write all that like I did there. It's just what is 11? It is one group of what? 7 plus 4 ones. Agree? So this would be like if I wrote it out in according to Hoyle expanded form. 1 times 7 to the first plus what? 4 times 7 to the 0. Just, but I can write that really quick. So, and I don't even write this one, but I'm going to write it here. That means this is 11 in base 10 is 1 what 4 base what 7. Are we good there? So I'm gonna go what, 4 and carry the what? The 1. And do this.
That's 8, so it's 1 over. So it's 1.
Yep. So that's gonna be 6 plus 2. Yep. So 8, and so one group is 7 plus what? 1. You already got it. And then, so that's a 1 in base what, 7.
I'm just, I don't know.
No, you're fine. It always takes everyone a few times before it starts clicking. Okay, so I'm adding, as I do these individual sums, I'm adding in base 10,
Okay.
even though this is base 7. So where did I get this? 6 plus 5 is what? 11. But then I take the 11 that I added up as like base 10,
Okay.
and I convert it to base what? 7. Then I said that's 1 for base 7. So I wrote the 4 and carried the what?
Okay.
Make sense?
Yeah.
Now I add a base 10 again. So I'm gonna go 1 plus 5 is 6. 6 plus 2 is 8. Then that would be 1, 1, base 7. 1 group 7 plus 1. Good. So 1 and what carry what? Now, 1 plus 4 is 5. 5 and 2 is what? 7. So 7. It all starts to make a little bit more sense. You know, if we were writing out the digits of what base, the numbers, counting numbers of base 7, when I look at 1, 0, 1, 2, 3, 4, 5, 6, in base 7, the next number will be 10 or 1, 0, right? 7 is 1 group of 7 and ones. So 0 and carry what? See how it works? Much quicker, much quicker, especially like say you were doing base 16. It's gonna be much quicker. Questions out there, you guys? We all good? All right, do another one. Let's do, another base. 5, 4 plus 1, 2, 3. And this time we're gonna work in base 6. All right. So remember, our process here is we're going to add in base 10 and then convert on each sum. So just make sure we remember what the base 6. So 4 plus 3 is 7. That's 1 group of 6 plus 1, 1. So it's 1, 1 base 6. So 1 and carry 1. That's going to add up to be 6. So that's 1 group of 6 and no ones. So 0, carry 1. And then sometimes like this, you're going to get what, 4? Well, 4 is a base 6 digit. So, and then 5 plus 0 is 5 and done. So it's just that quick. So technically, we're really still thinking what base 10, but we're able to do actually each individual sum and convert very small, conversions that we don't need a calculator for or anything like that. All right, any questions on addition? Well, so what we're going to do is proceed through all the operations. That would be subtraction would be next. So let's look at what we would do for subtraction. Now, in all honesty, historically, people actually prefer subtraction as an operation they have to do in another base. As opposed to addition. No. 5, 6, 3, 2. There's a reason. We'll see why in a second. Minus 3, 7. And we're going to make this in base 9. All right, so why did I do that? I'm going to go back up. Now, We could again convert 5, 6, 3, 2, base 9 to base 10, and 2, 7, 8, base 9 to base 10, do the subtraction of base 10, then convert back to base 9. We're not gonna do all that. So we're gonna work in base 9, that is do each individual operation. And thinking in base 10, kind of, but not kind of. We'll see here in a second. Now, you guys know, we're taught once upon a time, you got a what here? Well, carry over, right? Or maybe did you ever hear the term borrow? You got to go over the next place value and borrow. So because this digit is less than this digit. Now, back in the day, you were taught this convention. You would cross that out, reduce it by what? One digit. And don't write this on your paper. You would put a what? A 1 here, right? And you were told back in the day, because you were bringing over a group of what? What were you bringing? 10. Because we're basically, we were taught arithmetic in base 10. That was our numeration. And I'm not saying your teacher was lying to you. Because they really were. You really were bringing over a group of 10. I'm going to do this problem twice because I want to show you this convention of bringing over the 1 actually isn't specific to base 10. It's the same in every base, but we'll discuss that in a minute. So I'm not going to put the 1 there because I want to think this in base 10 as I do these each of the operations. So because these numbers are in base 9, I reduce that by 1. I just remember I am not bringing over a group of 10. I'm bringing over a group of what? 9. So what I'm going to do is I'm going to bring over the group of 9. In my head, I'm going to go 9 plus 2 is what? 11. And 11 minus 8 is 3. And that'll work every single time. You will always get a digit that is in that base. Okay? So then we keep going, same thing. I'm gonna have to borrow again. So got a 5. And I bring over a group of 7. 7 plus 2 is what?
9.
9.
Would be 9.
Just thank you, I don't know why, because of that, I'm sorry. 9 plus 2, which is what? 11. And 11 minus 7 is what? 4. Now I don't need to borrow. 5 minus 3 is what? 2. And bring down the 5 and done. And that's subtraction. Now, I'm going to do this one more time. This is not the way you're going to normally do it. What I'm doing, I want to make a point about something. And actually, I'm not going to do the whole thing. You've already done the problem. This is how you'll do it for subtraction. But speed start, this is based on. Cancel the 3. Reduce it by 1 because I'm borrowing a group of what? 9. Now, let's say I put the 1 here, like you were taught years ago. What is 9? Bring over a group of 9. 9 plus 2 is what? 11. Now we were thinking base 10. So what is 11? Oh, that's one group of 9 plus what? 2 1s. It is 1, 2 in base 9. So if I were able to what? Just think in base 9, not have to go through base 10 at all, this is exactly how I would write it. So that convention of bringing the 1 over, writing it in front of that digit, isn't actually specific to just base 10, but your teacher wasn't lying when she said, or he said, bring over a group of 10, because that's actually what we really were doing. But it's good to see, oh, this works in any case. We good with this? Subtraction. Okay, well, that leaves 2 more operations. that would be what? Multiplication and what? Division. So we're gonna do multiplication. That's very disappointing. in that.
Oh, yeah.
I don't like.
Somebody's got to root for him.
Well, on the suffering meter, I'm a Reds fan, so
Evens out.
more or less. When I was started rooting for the Reds, when I was a little guy, and they were a big red machine in the early mid '70s and winning the division, winning a couple of world championships, and I thought that's how it was always supposed to be. Little did I know. And so we had 90. So I guess you got a little bit more than me. You had this great bond for you. Which I guess it's been 79.
So it said play 70.
Yeah, 79 since you got it.
Way before I could watch. I never seen one. Probably never will.
You never know. You never know. All right, so we're going to multiply. And so 4, 5, 2, 3 times. 1, 5. We've done 6, 7, and 9, right? 6, 7, and 9. So this is 7. We'll work this multiplication in this 8. Okay. So we are going to use our same way that you were taught to multiply way back when. We are going to look at some alternative ways to multiply on Wednesday, aside from this method. So we're going to proceed in the way that we were all normally taught. And we're going to take what we did with addition and apply it here. That is, I'm going to look at each individual product as I go. Think of it multiplying in base 10. The numbers are going to be a little bigger, but they will still be small enough that we mentally are able to, for the most part, convert them, in our heads without having to go through any long, laborious process. Convert them to base 8 quickly and go on, which makes sense since multiplication is really addition, right? It's just repeated addition. So we'll start right here. 7 times 3 is what? 21. Now, 21 in base 8 would be what? 2 groups of what? 8 plus 5 ones. 2, 5 base 8. Good. And we're off and roll. So 5 carry a what? A 2. Now we go 7 times 2 is what? 14. Plus 2 is what? 16. Yep. 2 groups of 8 plus 0 ones. So it's 0, carry the 2. 7 times 5 is 35, plus 2 is 37. So that's going to be what? 4 groups of 8 plus 5 ones, 4, 5 base 8. So we have an 8, and we carry 4. We good? Okay, now 7 times 4 is 28, plus 4 is 30 what? 2. Have I done something?
That last one should be 5. But
Thank you. Yep. My bad. And they're still carrying 4.
yeah.
So that would be 4 groups of 8 and no ones. So now I'm at the last digit. So what I write is what? 4, 0. Now, what I do from here is I'm moving that to what multiplied by is 5, right? But we were taught way back when you got the placeholder. Because we're not really multiplying by 5, we're multiplying by 5, 0. Base. So it's placeholder. Now we're just gonna repeat the process. We'll go with 5. 5 times 3 is 15. Which would be one group of 8 plus 7 ones. Okay, so what I always do, I gotta carry what, a 1 here? I put it just above that too. So I know that's the one I'm gonna be adding this time. So 5 times 2 is 10, plus 1 is 11. All right, so that is going to be one group of 8 plus 3 ones. So 3 and carry 1. And then so 5 times 5 is 25, plus 1 is 26. So that would be 3 groups of 8 plus 2 ones. So 2 and carry 3. Oops, one more. My bad. There. And then 5 times 4 is 20, plus 3 is 23. So that's going to be 2 groups of 8 plus 7. 2, 7. All right, now put the 2, 7 in there. Now we got one more digit. I made that a 1 on purpose. 1 is going to be the multiplicative identity in any base. So anything times 1 is itself. Now I put 2 zeros here this time. Now 3, 2, 5, and 1, 4. Okay, well, it'd be nice if we were done, but we're not, because now what do we do? We gotta add up each one of these guys together. All right, so the same rules apply when we add here. These will all be base 8 digits. So I'm going to add how I was adding in base 8. That's going to be 5. 5 plus 0 plus 0. 0 plus 7 plus 0 is 7. Now that's going to be 8 plus 3 is 11. 11 we already know is 1 3. Start right here. So 3, there's a 1. Now that's going to add up to be 5. This is going to be 11 plus 5 is 16, which we have right here. It's 2, 0. 2 groups of 8, 0, 1s. Carry the 2. That's going to be 8. 8 in base 8 is 1, 0. 1 group of 8 and 0, 1s. And we are there. So it is 1, 0, 0, 5, 3, 7, 5. Basic. Good. Not necessarily having fun. But understand, that's too long. There's a lot going on there. For sure. I won't dispute you on that. Okay. All right. What time is it? All right, before we leave multiplication, I want to do one more thing. basic multiplication table. Now, officially, this kind of table is referred to as a Cayley table. It won't be a test. Now, Cayley, the last name of the mathematician, Sir Arthur Cayley, kind of came up with this idea. And basically, any set of elements combined with some binary operation or some binary operation that combines those elements, which means I can take these two elements within the set by however the operations define and come up with a third new element. So if you go on in mathematics, you look at all kinds of sets and all kinds of binary operations. In this particular case, we're looking at multiplication. Okay. So you can copy this table down later. Please work with me on it as I build this table. Now, anything times 0 is what? 0. So we can write zeros right down that way. And down to what? Column. Now, the nice thing about building this table, if I get a row, I get a column. And the reason is multiplication is a commutative operation. That is, I can multiply, reverse the order. 2 times 3 is the same thing as 3 times 2, right? So if I get a row, I get a column. All right, anything times 1 is itself, it's the multiplicative identity. Okay. Now we're going times 2. 2 times, now remember, it's in base 8. So 2 times 2 is what? 4. 2 times 3 is 6. 2 times 4 is 8, but that's one group of 8 and what? 0 ones. 2 times 5 is 10. That's one group of 8 and what? 2 ones. 2 times 6 is 12. That's one group of 8 and 4 ones. And 2 times 7 is 14, which is one group of 8 and what? 6 ones. Got that right. Okay, so now times 3. 3 times 3 is 9. That's one group of 8 and 1. 3 times 4 is 12. That's one group of 8 and 4 ones. And you start to see a pattern. This row is increasing by what? 3. That row is increasing by 2. So I predict this should be what? 1, 7. Let's see. 3 times 5 is 15, which is one group of 8 and 7 ones. All right, 3 times 6 is 18, so that's 2 groups of 8 and what? 2 ones. All right, so I do see that increasing kind of like, so looks like to us by 4, but so I did that. 3 times 7 is what? 21. So that's one group of 8 and what? Or excuse me, 2 groups of 8 and what? 5 ones. All right, so that gives me, finish up this column here, that would be 1, 4, 1, 7, 2, 2, and 2, 5. All right, onward and forward. So times 4. 4 times 4 is what? 16. That's 2 groups of 8 and 0 ones. 4 times 5 is 20. So that's 2 groups of 8 and 4 ones. 4 times 6 is 24. That's 3 groups of 8 and no ones. And 4 times 7 is 28. So that's 3 groups of 8 and 4 ones. And I can see kind of like, well, okay, increased by 6, then by 4, by 6. Kind of when I make that jump of what? I increase the next what?
So it's 2
Place back, yeah. But I definitely see patterns in here. Okay. 5 times 5 is 25, so that's 3 groups of 8 and 1. 5 times 6 is 30. That's 3 groups of 8 and 6 ones. And 5 times 7 is 35. So that's 4 groups of 8 and what? 3 ones. All right. So, kind of what, 7, then 5, 7. Increased by 5, increased by what? 7 again. Well, at least I see a pattern. And now I can put in my 3, 6, and what? 4, 3. All right, so 6 times 6 is what? 36. So that would be 36, 4 groups of 8 and 4 ones. 6 times 7 is 42. That's 5 groups of 8 and 2 ones. So this has to be 5 too. And one last one, and we've got this table done. 7 times 7 is 49. So that is 6 groups of 8 and what? 1. All right. So here's a test question for you. So at least back in the day, pre-pandemic, I've written tests. And, before we started the test, I would pass out one sheet of paper, and you were on the clock. Literally, so you've got 60 seconds. Right down the table. Which means what? If you don't know the table, you really don't have time to what? Do all the conversions, unless you spend some time actually what, those little patterns I was kind of doing. You really just have to have it memorized, right? Yeah. Now, I knew I wasn't going to get the reaction I was looking for today because I said pre-pandemic and back when I had written tests, and nobody's really freaking out because I'm not going to do it. But it used to be my favorite thing to do in the world because I've seen all kinds of varied reaction to people just looking at me like, please don't do that to me. To outright, anger or hanging an effigy outside the building or something, just so. And then I would say, no, I wouldn't actually do that. Right? So at any time, I've never actually done that. I've made people think for a minute. For a brief second or two, I was going to do that. Why would I put that kind of anxiety in you? You guys are going to go out and teach this one day. And one day, you're going to have to teach what the multiplication tables in base 10, because it needs to be rote. It needs to be 3 times 5 is 35. 3 times 5 is 15. 3 times 7 is what? 21. Where was I going with that? 5 times 7 is what? 35, right? And I actually really do know my but we all had to go through that painful process, and we learned all kinds. We had flashcards, and it's just rote memorization, which is a skill that you have to be taught. There's other things you have to be able to memorize and just know. But it's scary. And here's the deal. I see it. I mean, I teach adults, but I get adults that are literally cannot go 3 times 7 is 21. And we have to back up and actually look at building a multiplication table in base 10, making them do the repeated addition, actually making them go 7 plus 7 plus 7 is what? 21, put it on their table. And then use that table to do arithmetic without a calculator. Adults. And that's in our world, that's scary, not being able to have that skill. So you want that early on. So it is a very important thing to be able to do. But you have to empathize, because at your point, you can do it so quickly, you forgot how torturous that was to learn them once upon a time. In my case, it's third grade. And I went to a very rural school. We had these banks of like 6 lights in the classroom. I don't know, there was like 20 of us in there. And we came in one day and on one bank of light, the teacher had hooked string on then strings, a piece of construction paper she had cut out and neatly wrote our names, each of our names. And we started like ×1 and gave a test. And if we passed the test, which meant we got every one of them right, our name got to be moved to the next what? Bank of lights. And then the next week we did ×2. And then the next week ×3. Now, if you didn't get them all, you didn't get to move on. So the next week, if you didn't get to move on, she would allow you to take both tests, the ones from the week prior, and so in which case try to what catch up. And I will say, at the end of it all, once we got, I think we went through ×12. She had prizes. She went out and bought, some toys or something. I was one bank short. There were 2 kids that came in the finish line, first, and I was one bank behind. So that means I did not score perfect on every, because those 2 kids never missed. So anyhow, that was just what she did. I thought it was pretty clever. It stuck with me all these years. All right, so no, I'm not going to make you do that. But every group would have, every base would have its own multiplication table. And if we were working, as is always said, if we were born with 3 fingers and 2 opposable thumbs, we'd be working in base 8 and not thinking anything of it. These would be the numbers that we would know like that. So, okay. One last operation, what would that be? Division. Okay, so what would the division? So let's see how we break this up. Three, 4, 5, 6. I'll make that 4, 5 by 23. Let's make the base 6. Okay, so I'm going to start this kind of out like how we would do our normal division that we were taught way back when. Right, this 5, 2, 3, base 6, and 2, 3, 4, 5, 4. The problem now I can see that's ×1. 23 means 2, 3, 1 time. I can see that. That may not. Yeah, of course, I just made this up on top of my head. The problem, though, in general, is I won't know how many times 2, 3, base 6 goes into a number because I don't know by rote multiplication in base 6. So to do this division, what I'm actually going to have to do is construct a little table. Now we have to do this every time, whatever the base is. So 0, 1, 2, 3, 4, and 5. That is the digits of base 6. And then here, I'm actually going to go through and figure out what all the products is. That is 2, 3 times any one of these digits of base 6. So the first 2 are always easy. That's 0, that's 2, 3. And then I'm going to do some side work real quick. 2, 3 times 2. Now it's base 6. 2 times 3 is 6, so that's 0. carry a 1. 5. 5, 0. Base 6. 2, 3 times 3. Now 3 times 3 is 9. So that's one group of 6 plus 3 ones. And that's going to give you 6, which is 1, 0, base 6. So 1 and 3. 2 more to do. 2, 3 times 4, base 6. That's 12. That's one group or 2 groups of 6 no ones. 8 plus 2 is 10. So 10 would be one group of 6 and 4 ones. So 1, 4, 0. And then finally 2, 3 times 5 and base 6. 15, that's one group of 6. Wait a second. I messed up, my bad, back here. My alarm bell was going off as soon as I wrote it down. 3 times 4 is 12. That's 2, well, that's 2 groups of 6 here at once. So that's 2 groups of 6 and what? 3 ones. 15. 2 groups of 6. 12 and 3 ones. Right. That's 12, which would be 2 groups of 6 and 0, 1, 2. Once I have the table made, then I can use it and do the division. So the first one is really simple. It's going to go what 1 time. Now that will give me 0. Bring down the what next what digit. And 23 goes into 4 what, or 2, 3 basically goes into 4 0 times. And so what I would do at that point is now bring down the next what digit. But that 0 is important here. Now, for 4, 5, I can go to my table. It's going to go just what 1 time. Can't go twice. Twice is going to be 5, 0. So it's going to go 1 time. And then I'm going to subtract. Well, that's going to give me what? 2, 2. Bring down now what will be the last digit, and it's going to have to go 5 times. And so that would give me 203. So I never had to borrow on the subtraction part. That would be 1, that would be 2. And so it is 1015 base 6. Your remainder would be 21. We good? With division. Okay. All right. Well, write these down. This is I'm about to give you your homework. So it will not be on my map. So write her down, take a picture. So basically we're going to go through the operation. So if I have 1, 2, 4, 5, 6, base 7. So it's an addition problem. Number 2. Also an addition problem, base 16. Okay. Need a subtraction problem. Traction. Five, 3 minus 46. And this will be 86. Four. Let's do 5, 2. Times 6. 9. My favorite problem in the world. Multiplication. 16. Now note, I'm not giving you anything in base 2, which is obnoxious. But one last problem, 6 problems. We'll do one division. And let's do no, 5. Divide by and this will be 6. Okay. Can you guys out there see all the problems I wrote down?
I can't really see the first one. Could you tell me the numbers?
I sure can. And let me just do this. I'm gonna take the camera and put it up closer to the board.
Okay.
Can you see it now?
Yep.
Okay. 4, 5, 6, 3 plus 2, 4, 5, base 7. So, now here's what we're going to do in terms of this one I want to take. So, you've got 6 problems total in your arithmetic. So you should be able to do them on one piece of paper. So if you come to class, I'll just take it. Okay. You guys, what you're gonna have, you can't come into class, what you're gonna have to do is just do the work, take a picture and email that to me as an attachment. We good?
Yeah.
All right. So that will be the assignment and I will get this video uploaded and send you a link to it. Okay. So. And let me